We're going to overclock this machine until it hurts. Until it megahertz.
All right, so you're just telling me how this is going to be making waffles.
Yes, some overclocking waffles.
Yep.
So at this point, pretty much what we now need to go ahead and do is first select the Ai Overclocked Tuner. So this is just going to allow us to go ahead and get the board into a manual operating mode. Now we're going to have two options. One's going to be XMP, one's going to be manual. Now I'm going to go ahead and set mine to XMP, but a very important point right off the bat that we want to go ahead and clarify is that with this platform, as you increase the CPU frequency, you're going to have a higher level of difficulty to be able to sustain or be able to go ahead and actually achieve higher DRAM dividers. What that essentially means is that if I keep the CPU frequency up high, it's going to be hard to also keep the DRAM frequency up high. So ideally, when you first pursue the overclocking state, do not go ahead and set this XMP profile. It would be ideal to go ahead and set it to a manual and only make an adjustment to the CPU frequency, verify that CPU frequency, and once that's all been completed, then you go back and you drive up the DRAM divider, because not all CPUs will have the capability of driving high CPU frequencies and also high DRAM dividers.
Well, they get hot, and there's some spillover from the heat when you're running a high frequency on your memory as well.
Mm-hmm.
Now, we know that this memory can run at a higher frequency than 1333 out of the
Yes.
box, so we can go ahead and bump up with the XMP.
Yes, and that's entirely fine, but like I said, it doesn't take away from the fact that there are going to be Haswell CPUs that just don't support running at, let's say, 4.6 and 2400 memory. They might only support running at 4.6 and 1866. So just keep that in mind, is that there's going to be variance.
Yeah, not all of the Haswell CPUs are created equally.
Correct. There is going to be significant margin, and we'll talk more about that when we get into some of the other options. So from there, we're going to go ahead and go down. Now, you're going to see that there is an option such as the CPU strap. You don't need to actually worry about this. Overall, if you did want to go ahead and overclock via a secondary method, you could use a CPU strap, but for all intents and purposes, it's going to be easiest and most successful to do it through the CPU ratio, or what's referred to as the multiplier.
Now, for just for the noobs and the guys that have never done this before, CPU strap is back, and it's been on X79, and I love using this. But this is like your front side bus.
Yes.
And can you explain exactly what it's doing so that the new guys can catch up?
Pretty much, this is going to be the kind of the BCLK, or like you noted, what in the past might have referred to as the front side bus. So this multiplied
front side bus, yes.
Yeah. So this multiplied times your ratio would give you your new corresponding CPU frequency. There is some benefits to it. The reason why Intel has reintroduced it back into this chipset, as well as why they had it in X79, is to be able to have more granularity. So I'm going to show you an example of what granularity is. If I go down right now to the DRAM frequency and I select this, you see that I have different types of memory dividers available to me. So 1800, 1866, 2000, 2133, 2200. If I use a different type of actual strap, I can actually have different types of DRAM dividers, because we're influencing the total base clock where the multiplier is working against. So if I go ahead and set something like 125, and I now head over, you see how now it's automatically made adjustment to my DRAM divider.
You don't want that.
And
That's
I
too
can
high.
go ahead and see now that you see I have an entirely different set of DRAM dividers. Now, where this is actually interesting and potentially helpful is, keep in mind, if let's say I've gone ahead and successfully overclocked my CPU, and I've got a set of 2133 memory, and I can't successfully go ahead and hit 2133, but I know I can hold 1866. Sometimes having that more granularity that the BCLK or that the strap might provide you can give you maybe a targeted frequency in between those.
Maybe you can hit
They could be
2000.
hold. Yes.
Yeah.
So that might be an option. Now, previously in previous generation platforms, you actually had to use the strap to be able to have the 2000 memory divider, but we have more memory dividers under this platform than we've had under previous generations.
So
but
you
the
can
best,
independently clock them?
yes, you can fully asynchronously support this. But keep in mind that because this will also dynamically overclock the memory as well as the CPU, it's going to be a more complicated as well as generally a more stressful overclock. But in some situations where you have also weaker CPU cores, so where CPUs maybe can't actually get to a native multiplier 46.
And 46, for people who do not know, 46 will give you a 4.6 gigahertz
because it's
gigahertz speed.
Correct, because it's multiplying it against, once again, that baseline value. So if we go back here and we go to 100, that's our baseline value. It's all just basic math. So if we go ahead and we type in that 46, it's 46 times 100, right? Gives us 4.6.
Yeah.
Well, if we changed the, of course, the strap again and we went to 125, you'd see we are at 5.7.
That's way too high. So
yeah.
you'll need to go down and change the multiplier. And I usually do this with a calculator.
Yeah.
I sit down with a 125 megahertz CPU strap, and then you you just set it to something that's reasonable, but
Yeah.
around the target that you were trying to hit with the multiplier
Right.
alone, and maybe you can achieve a different result.
Yeah, you
From
can.
my experience.
You can sometimes, and in this platform, you're probably not going to.
Yeah.
But the advantage that you're going to have is, like I said, under certain situations, we have seen that some CPUs do not allow for reaching a native CPU multiplier. So you may be able to reach past that frequency through the use of the strap, BCLK, and some multiplier. So it's just a different way to be able to
That'll
achieve
be
the result.
maybe with a non-K CPU, you could have some maneuverability.
Some very moderate overclocking.
much.
Yeah, but it could come in helpful as maybe if you have a very low quality CPU in terms of the maximum margin. So maybe it only gets up to 43, but maybe via the strap and making some adjustments, you might be able to maybe get 44, 45.
Yeah. So I wanted to cover that for the people who really do not know what that means, because I think we do have some who are advanced.
Mm-hmm.
And they'll really enjoy some of the more advanced parts of the tutorial, but some who, we may feel left out if we don't cover that.
Well,
so.
I think definitely at the end, we're going to recap literally a 3-step process. It's going to make it really easy for people that don't really have almost any understanding. But for that, I would probably say you're better off using our CPU level up or our 4-way optimization.
Right. All right, I'll let you take over from here. I wanted to make sure people understood the strap.
No worries. So from here, we're just going to drop down now to our core ratio. You're going to have two options. Either go ahead and pick sync all cores. This is the way most of the manual diehard overclockers select this. And then what that means is we're going to lock 46 across all of our cores. Now this is definitely a fine option, but in some situations, if you go ahead and select per core clocking, the advantage could be is that your CPU may actually have some cores that might not be able to fully reach that multiplier across all cores, but they might be able to do it on 1 and 2 cores. So as an example, we could go ahead and maybe set 47 for 1 and 2 cores, right? And then we could have 46 for the last stage cores. So that's really up to you, but once again, to keep this in a simplified configuration, we're going to go ahead and just sync all cores, and we're going to choose 46. Now, the next option is going to be this CPU cache ratio. The cache ratio is what's now referred to as the ring bus, and in previous generations might have been called like the uncore. This is very important in terms of total system performance, or what's referred to as IPC. The faster this cache ratio runs and the closer it is to your actual core ratios, the better the performance. Now, our motherboards have a fantastic set of auto rules where if you go ahead and define the core ratio, we'll automatically define the core ratio for you, CPU cache ratio, so that you get optimal scaling. But if you want to ensure 100% fastest performance, you can force a native cache ratio as an example.
Change them to the same.
Exactly. And that would give us the best absolute performance. Now, in some situations, you're going to find that there is CPU margin where the CPU is not capable of running the native core ratio and the native cache ratio. In that situation, either you can default back to the auto values, or if you wanted to manually tune it, we recommend a target between about 100 to 300 megahertz underneath the primary core ratio. So that would mean 46 would give us maybe something like 43, right? So we could go ahead and type in 43 and 43, and that would still allow us to potentially maybe bump up. Now, another area where you can use this is, let's say we do everything, you stabilize 46 and it's great, and you want to get to 47. You keep increasing the voltage, and you've got more headroom, but you're not able to stabilize that. What you can also attempt to do is reduce this cache ratio. Once again, our board has auto rules, so you probably don't need to adjust it. But let's say we tested 46, everything was great, we tried 47, we couldn't stabilize it. You would try 47, and then you would lower that cache ratio.
Yeah, and I would recommend probably benchmarking with both everything at 46 and also with it at 47 and the lower cache ratio, and seeing which produces better performance in the programs that you use.
Correct.
Because sometimes you'll find that 46 all the way across the board is better than 47 with a lower cache ratio.
That's correct, because ultimately native cache ratio is going to give you the absolute best performance. But in most situations, core is still king, so you probably would prefer to have a higher frequency with a slightly reduced ring bus.
Yeah.
So the next option is going to be PLL over voltage. Some of you guys might be familiar with this from previous generation platforms. Really, there's no reason to have to manipulate this option. It's built into the CPU architecture as a default. We have found some very odd variances on very small amount of CPU samples where potentially forcing the flag to be enabled may potentially help you to bump up one multiplier or a certain turbo bin. But in most situations, you're going to want to leave it to auto. But if you want to try a Hail Mary option just as a possibility, you can go ahead and try to enable it. But keep in mind that it can sometimes have adverse effects. So in most situations, auto's fine, don't worry about it. But if you want to try something as a Hail Mary option, it's there for you. Now, the next option is going to be if we drop all the way down to voltages. Now this is where you have quite a bit of options. If we go ahead and select this, we're going to see that we have a manual vid, an offset, and adaptive. So to clarify, manual is pretty straightforward. This is 100% fixed static voltage. If I go ahead and select manual and I put 1.2 volts, that means at any time that I'm utilizing my CPU, whether it's at idle, whether it's at moderate load, or it's at 100% load, it's always going to provide 1.2 volts. Now, by default, this architecture has no change in overall overclockability in terms of changing any type of power savings technology. So things like C-states, Intel speed step, all those items, you can leave those on and you can have your CPU throttle down in terms of CPU frequency, produce less low temperatures, reduce power consumption, and ideally, you would also want to reduce the voltage that's being supplied. With a manual voltage, it's not efficient. It's going to keep that voltage fixed the entire time. Some users at the absolute highest level frequencies, it may be sensible to use a manual voltage if you're going to force the frequency 100% of the time and you always want it to stay constant. You may not want to have a reduction in voltage because you may have instability. But in our testing, we've been able to successfully complete overclocking 4.6, 4.7, 4.8 using adaptive base voltages.
Now these CPUs are very efficient, but when you do this, they actually use a lot of power.
Yeah. So the next part right here is that I'm targeting in a 1.2 level of voltage for your CPU. This is going to be a very easy test for you guys. If you get your CPU, type in the 46, type 1.2 in, and at this point we're only going to have a couple of other settings to literally consider, but at this point you could hit F10, and if your system was to go ahead and post and boot and run some basic stability tests, you've actually got a pretty good quality CPU. It's actually borderlining probably a great quality CPU. If your CPU does not boot, and let's say you're using something like a Windows 7 and it gets past the post and you see the ball forming, right, that ball logo that occurs,
yep,
and it locks there, or it has a stop error, or what's referred to as a blue screen, that probably means that more voltage is required. So you would want to try basic increments. So 1.225, and then you would want to go ahead and once again you could try another voltage. So we could go ahead and try 1.250, and you would want to keep stepping up. Now realistically, if you're using a thermal cooling solution up to about like a closed loop radiator, 120 millimeter fan like a Corsair H80 type of cooling solution, you really probably don't want to use more than about 1.25 to 1.275, especially if you're going to use synthetic stress test applications.
If you're running like Prime 95, which I would not recommend with this platform.
Correct. I would not recommend it because it's not validated. So keep in mind that when running these type of unvalidated applications at 100% load at voltage points of 1.25 and 1.275, you're going to be near or at approaching thermal throttle, so 90 C plus temperatures. Under real world gaming conditions, normal applications, you're actually going to be entirely fine. The temperatures will be pretty consistent with probably a vicinity of somewhere between about probably 60 C to about 75 C. So actually very solid, even all the way up to 1.275. Even for some considerations, actually up to 1.3 is okay. But if running synthetics, you have to be very conscientious of that.
Yeah. If you're going to run synthetics, call the fire department first. Have them waiting outside.
It is something to keep in mind. Now keep in mind that another very big variation point is that for these CPUs, there's a large amount of voltage variance for the same CPU frequencies, and not all CPUs will be the same. So as an example, we're showing you here a great way to baseline test your CPU to see how good the margin is at trying 46 at 1.2. But to give you guys an effective range of understanding at the range of voltage, we could have a 46 capable CPU of doing 4.6 at 1.115, which would be an outstanding, literally an amazing quality CPU, to a 4.6 CPU that would require as much as 1.4 volts. That is a very large delta swing, so you have to be conscientious of that, and once again keep in mind of what your thermal solution is going to ultimately allow you to be able to successfully overclock towards. So with that, we've got 1.2 defined in. We don't need to worry about literally any of these other voltages. The only other voltages that we may want to go ahead and consider are going to be if we went down here, and these are called the CPU analog I/O and the CPU digital I/O. These are specialized voltages that handle the way that the memory controller works with the DRAM, and sometimes fine-tuning these can help to allow to increase the DRAM divider. So if remember, we went all the way back to our XMP, right? And right now we have the memory still running at 1333. Let's say we fully pass 4.6 at 1333 or even at 1600, and we've got a higher performance kit. We try everything out and it's still not stable, right? But we really want to try to get to maybe run 2133 or 2400. Then you could go ahead and apply that, then come down here and you could define in a voltage parameter of between 1.150 all the way up to maybe about 1.250, but definitely no more than that. And the key item here is not more voltage is better. It's more of a question that there are specific CPUs that prefer a certain level of an I/O voltage to allow it to be more compatible and tuned to that memory divider into that ratio. So it's a question that one CPU might like 1.2, and another CPU might like 1.225, another one might like 1.250, and another one might like 1.150. But it's definitely not that more voltage is better. Literally every CPU will vary. But the best way to try this is don't even make any adjustments at all. See if the CPU quality will allow this to run at the automatic default operating value, where we've already gone ahead and made some tuning adjustments. But if you want to manually try to go ahead and improve that, you can go ahead and try this.
So that would be like the first thing you would tune if the auto does not work.
Correct, and more so really only specific to that if you're trying to drive a higher CPU frequency with the RAM in concert, right? So at this point, let's go ahead and just read back over quickly in terms of what are the basic requirements of what we need to change. We would go to AI Overclocked Tuner, enable my XMP. Then from there, I can go ahead and go to my sync all cores, and I go to 46. For the multiplier, we could go ahead and set a native cache ratio as well. So 46 and then 46 here. And we could go ahead and go down to the core voltage, and we could go ahead and define 1.2 volts. So literally all we've done is add voltage, define the core limit. You didn't even actually have to touch the cache ratio. We could have left that 100% in auto, and we enabled XMP. Our motherboard is going to take up care of every single other setting automatically for you. So it's a very simplified level of operation. At this point, all we would need to go ahead and do is, this is not required for you, but our system is enabled in a RAID configuration, as well as we have a water cooling setup. So I need to go ahead and disable the monitoring here.
And these are things that people that are not doing exactly what you're doing would not need to do.
Correct, would not need to do. You 100%. Most likely running a single hard drive, just leave the rest of the settings. At this point, the motherboard is going to attempt to reboot, take those settings in. If it passes the post, then it goes through the boot and even gets into Windows. You could go ahead and run a number of different types of stability tests. As I noted, I like performance test from Passmark. Passmark's a burn-in test. I like ASUS if you want to run a high-level synthetic that's actually been validated. But there's other general usability tests such as PCMark, and there's even a new version that even has a very advanced level of real-world instruction sets. And even for you guys that really like ROG, we have a brand new system utility which we've shown you guys behind closed doors with ROG RealBench, which is a pretty awesome real-world stress test utility.
Yeah, I like them because they're all open-source real programs.
Correct.
And that makes me happy.
So you can see our system posted and booted successfully, and we're good to go. So at that point, you could go ahead and run different options, whether you wanted to get into your operating system and let's say run something like ASUS where you could run the benchmark report, and you could then check to see if you have stability. You could run something like Cinebench. It's really entirely up to you. So at this point, we're just lastly going to go ahead and reboot back in, show you the quick values for 4.8, and that's going to round out how to work with it as well, how to manually overclock it, and some of the points to consider. Okay, so now we've gone ahead and go back into the UEFI, reset the board down to defaults, and let's say we want to go ahead and target what would pretty much probably be the absolute best that you're going to get on Haswell, a 4.8 gigahertz overclock. So once again, we're going to go ahead and set our manual divider, but because it's so aggressive, this is where we really want to be conscientious of. 4.6, 4.7, and 4.8 overclocks, you really don't want to stress the CPU and the memory controller abruptly, so I'm really recommending that first and foremost, try it without having the memory divider high, and then you can go back and make the modifications that we've talked about in the past, where you can set the memory divider to such as something like XMP, and if you need to, you could consider making those adjustments to the I/O voltage, right? So manual, we go to the all cores, we're going to define in 48, right? Same thing here. Only the absolute best quality CPUs are going to be able to sustain 48 natively on the core ratio, as well as 48 on the cache ratio, or that ringbox frequency. To allow for the smoothest level of scaling though, keep it on auto as we have here, and then we're going to drop down lastly to go ahead and go to our core voltage, where we're going to go ahead and choose 1.275 volts. Once again, this is going to be a great option. If your CPU is capable of doing 4.8 at 1.275, it's great, but there are definitely going to be CPUs that require 1.3, 1.2325, 1.4, and even greater levels of voltage. And as I said, really only with something extraordinary in terms of your cooling solution like this coolants unit are you going to comfortably be able to drive 1.3 plus volts, especially if you're going to be running very high level demanding stress test applications or programs that require 80, 90, or 100% CPU load.
Right, yeah, you really, really need high quality cooling, and not just a closed loop cooling system. You need like custom
Correct.
water cooling.
Custom real water cooling, with definite being a minimum high performance double to not triple radiator configuration. And that's, like I said, only if you're really running those highest level of stress test applications or real world programs that are heavily hitting the CPU.
Yeah, I mean, most games do not tax the CPU at 100%
no,
all the time.
No, and we'll actually show that quickly when we get into Windows. So at this point, we've shown you, all we did was we did 48. We went ahead and defined the multiplier and our voltage, and that's it. So once again, I need to go ahead and set back my RAID, and I need to go ahead and disable my fans, and we're going to go back into Windows, and that's it. So you can see from an ease of use standpoint, whether it's going to be our Dash A, whether it's a Pro, whether it's a Sabertooth, whether it's the Hero or the Maximus 6 Extreme, it's a very simple level of options in terms of the UEFI, but there are quite a bit more parameters that you have to be conscious of, whether it's relative to the temperatures, the variances in the voltage, or other parameters of concern on how you're tweaking and tuning your system. And as always, you do want to keep in mind that overclocking is a variable endeavor. There is going to be margin of differential, as well as there's always the likelihood that you could potentially damage or shorten the lifespan of your part. So we've now gone ahead and got into the operating system environment, so we're good to go. So at this point, if I wanted to go ahead and check something, I could go ahead and, let's say, open up my Ada, and I could open up something like our benchmark report wizard, and we could go ahead and run the benchmark report. Now, right before I run that, I just want to go ahead and give you guys some temperature variable information. So if we go ahead and open this, we can actually see right here that we have actually successfully were running 4.8 gigahertz, and we actually ran this for 20 minutes. And a key thing to register is that the DTS sensors inside there have variability at the temperature they're picking up. So you can actually see that the peak temperatures show up all the way here on actually per core to be 90 C. But in actuality, when measured in their average over time, you can see that we're only effectively hitting just about 70 C. Mm-hmm. So that's actually extraordinary, but you're having almost a 20 C shift in terms of the temperature. So it's very important that if you're reading your program through a third-party program, don't just follow the initial baseline of the immediate temperature report. You need something that's going to help to provide you a composited average of what the temperature is over time.
Right, and you want to make sure that the maximum never hits your TJ max.
Correct. And we're still quite a bit underneath that. The thermal junction max is approximately about 100 to 105 C for the CPU. So our goal is really to keep this average temperature as low as possible. But ideally, of course, if we can keep the maximum even lower, that's ideal.
Yeah, the motherboard looks pretty good here too.
Yes. So here we're very solid, we're good to go, and at this point you could go ahead and run the benchmark report to verify something like your stability, and you could decide to run whatever other applications you want. But overall, that gives you some context and some insight in terms of how to tweak, tune, and overclock the platform. And like I said, remember, if we've gone ahead and completed this higher level overclock, we could simply then go ahead and set the XMP profile if we're using XMP enabled memory, and see if it would be able to pass our stability test. If ultimately it couldn't pass the stability test, whether it was from the DRAM divider in XMP or improving the cache ratio to a native cache ratio, you might just not have that within the margin of the CPU quality.
Now, I would want to say, like, after you finish this, you have a good CPU.
Mm-hmm.
I personally would probably go back in to the UEFI and then change it to like an offset mode.
Yes.
To save some power and also so that it doesn't run as hot.
Adaptive is going to give us the best efficiency, and it's also going to help to ensure that when we define that voltage, when the CPU frequency comes down, the voltage comes down. This helps to reduce power consumption, thermal load, and even characteristics of what's called voltage degradation. It means that we're not conditioning the CPU to that higher level of electrical voltage. Now, if you're able to run your chip at more conservative levels, it's a little bit more okay, but ideally adaptive is going to be far, far better. And you can see right there, this is the disadvantage of a manual voltage, right? Because we can see even when the CPU frequency is coming down, we're staying locked in at that 1.275. If we're using that nice adaptive voltage, which if you guys want to target something in, you're probably going to be looking at something like 200 to about 0.250 in terms of that adaptive range. That's a great level of flexibility. Now, the last thing is we didn't show it in the DigiPlus power settings, and I guess we can just reboot really quickly to show you this, but a lot of people always ask about load light calibration. You've used low light calibration probably for every generation in the last couple of years to compensate for what's called droop, right?
Yeah,
or when you overclock, you would set a voltage, but when you would go under load, the voltage would drop. But with the way this new CPU architecture works, and we have the fiber in place, the great thing is essentially what voltage is what you get. So that means
there's really no droop this time?
There's no droop. So it's a really flexible design implementation in terms of making this much easier. So if you notice, I set 1.275, and what did I get? I got 1.275 approximately. So I don't have to worry about that. So even though we have options in here that allow you to adjust the CPU load line calibration with various levels of granularity, this is actually only affecting the external PWM controller on the motherboard, and in most situations will not impact the stability of your overclock. If you wanted to really maybe fine tune something, you could set level 1 to try to give you maybe the maximum level of efficiency. If you want to try to ensure that you're just eking out just a little bit more voltage, you could set it to level 8. But because the fiber is really the driving controller at the voltage that's being supplied to the CPU, for all intents and purposes, you can forget about LLC or defining anything for it and just leave it to auto characteristics along with the extensive range of options. Now we have tons of specialized parameters here that you can tweak and tune, but in reality, we've done all the auto variability for you at 4.6, at 4.7, at 4.8, and we'll tune all these parameters for you, and you do not need to adjust them.
Yeah, usually I'm afraid of auto because auto means it's not going to work. But on these, from my own personal experience, Windows done this as well. Auto really seems to work.
Well, as you saw, all we did here, right, is we just went in and we put in 48, and we put in 1.275, and we hit reboot. That was it. That's all we changed. So it's a very, very simple process to be able to go ahead and take your overclocking into mindset to be able to go ahead and get these results. So just keep in mind that the voltages that we have provide are probably best of case scenarios, and only the best quality CPUs will hit that. If you're lucky enough to go ahead and run those frequencies, sign off on the checkbook and say you've got a great CPU and don't lose that guy.
Yeah.
But if not, you might need to go ahead and keep raising those voltage increments as we've noted.
Before we leave, I just want to make sure we go down and show them where the adaptive voltage is. Can we do that really quick?
So we can go back, and we highlighted that earlier. You can just go ahead and go here into your voltage tables. And if we just reload back our optimized defaults, you'll see that by default on the ROG series, but not on the other series motherboards, this will enable fully manual mode. So manual mode will be enabled by default. But on non-ROG enabled boards, it will actually be in adaptive mode by default. So if we just set this to disabled, we can now go ahead and select CPU core voltage, and we can select either the manual, or we can select the offset, or we can set adaptive. Now, for offset, this is essentially an older version of what the adaptive policy offers, and it's not as efficient because even at idle frequencies and idle voltages, if you still define an offset, it will still increase that base level voltage even at a minimum level. Adaptive will never modify the base frequency and the base voltage, so it'll only extend the voltage just when you get into the turbo states.
Yeah, and do not run, again, the synthetic benchmarks like Prime 95 with adaptive.
Correct, because you will have that huge increase in the amount of voltage being supplied. So just keep in mind, as long as you're doing that and you're running real-world applications, you don't need to worry about doing that. So any game, even complex rendering programs like Blender, POV, or anything like that, we have not found that that adds any voltage increase requests. It's only those unvalidated synthetic applications.
If you guys have any questions, there's a link in the description that's going to take you to this video on our website, and beneath that there'll be a comment section, and a lot of us will be in there to help you guys out with any questions you might have.
Yeah, and I think also I'll throw up our actually complete extensive overclocking guide into the Tech Syndicate forums that will detail actually all this out in a written form with screenshots for the boards, all these same options with even a lot more depth on specific parameters if you have more details, so you guys can go into the forums, post those commentary and questions and feedback if you want a little bit more information or affirmation out of what you've seen in this video.
Awesome. Thanks a lot, JJ. It's very helpful.
Thank you.